Hello, Doctor. We are from Group 6. Today, we're going to do the proposal presentation for experiment number 1. The title is Effect of Different Additives on Drilling Fluids and Filter Material Properties. So, this is the presentation outline. We have introduction, theory, methodology, result, expected results, and expected conclusion and references. So, experimental background. So, what is drilling fluid? Drilling fluid is the mixture of solid, liquids, and gases, which is important to increase the efficiency of drilling process. So, why it is important? Because it does plays a variety of roles, like including lubricating the drill string, cooling down the drilling equipment, preserving the integrity of the wellbore, and bringing the cut bits from the bottom to the surface, like that. So, adding various additives is one of the techniques to enhance the performance of the drilling fluid. So, in order to have the mud separate the particles and flow out of the hole, so you can, like for example, you can say the additive might thin the mud. So the effect of additives on drilling mud qualities has attracted much interest lately. Drilling fluids rheological quantities have been thoroughly investigated for additives like barite, hydroxyl cellulose, and carboxymethyl cellulose. So CMC and HEC are water-soluble polymers that enhance the filtration and viscosity of drilling mud. But barite is a heavy weight addition. It is good for efficiency in raising the density of drilling fluid. Next. So, a coating of solid drilling fluid particles called mud cake. Okay. Mud cake will reduce the fluid loss and shield the wellbore from instability. So, therefore, the thickness or other characteristics of the mud cake are crucial. Okay. So, different chemical additive formulas may affect mud cake's thickness and properties, which can affect the drilling efficiency. So, next. So, problem statement. Our problem statement is how does the additive affect the rheology and filtration properties of drilling fluid? So, objectives. First, we want to find to investigate the relationship between rheology properties of the drilling fluid and additive. Second, the relationship between the filtration properties of the drilling fluid and additives. And thirdly, to investigate the relationship between the density of the drilling fluid and additives. So, hypothesis. In this experiment, we're going to use 3 additives, CMC, starch, and barite. So, when CMC is added, the yield point of the drilling fluid will increase. Okay, this is our expected hypothesis. When starch added, the filtrate volume will decrease. When barite added into the drilling fluid, the density of the drilling fluid will increase. This is our expected hypothesis. So, the scope of experiment, we're going to fix the composition for controlling drilling fluids and manipulate the type of additives. As I mentioned earlier, we're going to use 3 different additives. And we're going to study the mud density, gel strength, yield point, plastic viscosity, filtrate volume, and filter cake thickness. Next.
Good afternoon, everyone. And now I'll be explaining the theory part of our experiment. First off, the influence of additives concentrations on rheological properties. The first one is the carbamazepine cellulose, or in short, CMC. It's a water-soluble polymer widely used in drilling fluid for its ability to control fluid loss and modify rheology. Derived from cellulose, CMC's solubility is enhanced by its substituent groups, CH2, COO, and Na positive, making it effective in various applications, especially in the oil field operations. And now I'm going to state some of the influences of CMC on the drilling fluid properties. The first one is plastic viscosity. The higher CMC increases plastic viscosity by enhancing shear thinning properties. The yield point. Low DS CMC improves our yield point, aiding in cutting suspension. Fluid loss. The CMC reduces the filtrate loss by strengthening the filter cake. In summary, CMC improves drilling fluid performance by controlling fluid loss and enhancing rheology, with its molecular characteristics directly affecting the fluid behavior. Next. Starch. Starch plays a key role in enhancing the performance of water-based drilling fluids. The concentration of the starch additives affects the following properties. The first one is plastic viscosity. Increased starch concentration leads to higher PV, which improves the fluid's ability to resist shear stress and maintain flow properties. The second one is yield point. Higher starch concentration increases the YP, improving the fluid's ability to carry drill cuttings. The third one is fluid loss. Higher concentration of starch reduces fluid loss, enhancing the sealing ability of the fluid and minimizing reservoir damage. Next. Barite. It's a key material used in drilling fluids to control their properties. For example, increasing the concentration of the barite affects the following. The first one is the plastic viscosity. As barite concentration increases, the plastic viscosity also increases. The yield point. The yield point also rises with higher barite levels. This shows that the fluid gains more strength to carry drill cuttings. Fluid loss. With more barite, the fluid loss or filtration volume increases. This means more fluid is lost through the filter cake, which could be a challenge in drilling operations. In addition, the density and the pH value of the fluid go up as the barite concentration increases. The filter cake becomes thicker and more permeable, but its porosity, the space between the particles, decreases with more barite. Overall, while the barite improves the fluid's strength and sealing ability, it also increases fluid loss, which needs to be carefully managed. Next.
Okay, for the For the metallurgy, material and apparatus, material we use CNC, barite, starch, methanol, and water. For the apparatus, we use mud balance, viscometer, low pressure filter press, mud mixer, and linear caliper. For the procedure, first we prepare the betonite base mud and separate into 4 samples. The first sample act as control. Second sample is mixed with 35 grams of barite. The sample is mixed with 7.5 grams of CMC, and the fourth sample mixed with 7.5 grams of starch. Third, we evaluate and record the density of each sample by using a mud balance. Fourth, evaluate and record the rheology measurement of each sample by using a viscometer. Fifth, evaluate and record the filtration properties of each sample by using a low pressure filter press. Record the thickness of the mud cake by using a linear caliper.
So now its expected result. First, we will calculate the mud density using the samples, which is control, CMC, starch, and barite. Next slide. So followed by rheology properties. As usual, we will do the reading for 3 RPM, 6 RPM, followed by 100, 200, 300, and 600 for the samples of control, CMC, starch, and barite. After that, we will do the yield strength properties, which is 10 seconds and 10 minutes for the same sample. For the filtration properties, we will use the same sample to calculate the filtrate volume using the time interval 10 minutes, 20 minutes, and 30 minutes, and followed by the filtrate thickness. We will do the filtrate thickness for 3 reading for the same sample. Next slide.
Assalamualaikum, this is Adnan. I'll be doing the conclusion part. In this experiment, by analyzing core samples, we expected an increase of the density of the drilling fluid, as we showed in the previous page. By using the formula of total density, these are the rates, calculations which we need in this experiment. By using additives such as bentonite, barite, starch, and CMC, we expect the change of the density of the drilling fluids. By understanding and selecting the right additives, drilling fluid performance and the filter cake properties can be optimized to meet operational challenges, ensure efficient and safe drilling operations by minimizing environmental and formation damage. Thank you.
This is for the reference. That's all from us. Thank you.